Welcome to qnawire.
So in this problem, we're trying to figure out if a car can pass a truck safely. So I'm just going to draw what situation we have right here. This is, I'm going to call car 1, and it's traveling at 25 meters per second. And in front of it is a truck, that was capital T, and they're separated by 10 meters. The truck itself is 20 meters. And then the car also wants to clear the truck by an additional 10 meters. And then we have a car coming in the opposite direction, car 2. And this, well, the speed is 25 meters per second, but it's going in the opposite direction. So we'll say the velocity for this car is negative 25 meters per second. And then the car is separated from the other one by 400 meters. So if this car 1 can accelerate at 1 meter per second squared, is it going to be able to pass the truck safely? So first I want to figure out how long it will take for this car to go around the truck and into 10 meters in front of it. So for that, first I know that for the car, we know our velocity is 25 meters per second. Same for the truck. And the acceleration for the car is 1 meter per second squared. And the truck's just moving at a constant velocity. And now the car, we know the car has to move however far the truck moves, plus an additional 40 meters for this distance. So delta x of the car is going to be delta x of the truck plus 40 meters. And that should be enough information. So we know delta x of the car is going to be given by the initial velocity times time plus 1/2 at squared. And delta x for the truck is just going to be its velocity times time. This is velocity. And then because of this, we know that delta x of the car, which is represented by this, is going to be the velocity of the truck times time plus an additional 40 meters. Now we can solve this equation for time. So we know the initial velocity of the car is 25, and our acceleration is 1. The truck is also going at 25 meters per second. So this means that we can cancel out some terms, and now we just get t squared equals 80. So t equals root 80, which is about 8.94 seconds. So that's how long it takes the car to pass the truck. Now let's see how far the car went. Well, we already know from up here how far the car went, or at least an expression for it. It's going to be, well, let's see, V0, still 25, but now we know our time is 8.94 seconds. And then plus 1/2 times, well, times 1, times, now we have t squared. And this gives us a delta x of 263.46 meters. And so that 263.46 is going to be this distance, however far the car gets. And so that means this distance on the right of the 400 meters is how far car 2 is going to travel, or how far it can before it's not safe to pass. So this distance over here is 400 minus what we got down here, 263.46, which is 136.54 meters. So now as long as this car 2, traveled less than 136.54 meters in the time that it took the first car to pass, then it will be safe to pass. So let me go back up here. The delta x for car 2 is the same expression as we did for the truck. It's just our velocity times time. And now we know our time. So it's going to be negative 25 meters per second times 8.94 meters. And this is going to give us 223 and a half meters. Well, negative is the displacement, and that just means that car 2 is going left. So if car 2 is going 223 and a half meters to the left, and it only has 136 and change to make for car 1 to make safe passage, then we know that car 1 will not be able to pass the truck in time, and so it's not safe.